Once again, I think we are going with a very important chapter, that is programming of 8085. I think before this we have already done with many uh, groups. I think data transfer, arithmetic, logical. Now we are going with a branching group of instructions. So very important, because if we learn from this, I think jump instruction, then we can easily understand all the programs from your TPS or from your 12th standard syllabus. Okay, so please pay attention. Okay, I'll just try to explain you this group. Branching group of instruction. Branching instructions alters the normal sequential flow. These instructions alter either conditionally or unconditional. So you can say that all the branching instructions are either unconditional or conditional. Branch operations are of two types: unconditional branch and conditional branch. In unconditional branch, go to the new location no matter what. No matter what means the commanders got the order, so they will not listen to anyone. They will do as the instructions. Okay, but in conditional branch, go to the new location if the condition is true. If the condition is true means they will think whether it is logical to attack or not. Okay, but I think in unconditional they don't check any condition, but in conditional they check conditions. Okay, now let's go with I think if you understand this instruction, jump instruction, then you can easily understand all the programs, because it is mostly used for looping or to transfer the control from one position to another position. So I think we have already seen if, else, then for loop, different loops we have seen. So I think it will try to cover that. So in unconditional jump instruction, we are having only one, that is jump address. So jump unconditionally, the control is transferred unconditionally to the memory location whose address is specified in the instruction. So you can say jump 2500H. So jump unconditional to this memory location. This instruction belongs to immediate addressing mode. Okay, and this is 3 byte because of address. Okay, flags are not affected. And remember that in this program counter is also used. I think when I'll explain you the program, that I'll just talk about this. Right now you just remember that you after jump you have to write address. Okay, now conditional jump instruction. So can you see I've just written JX. X stands for many conditions here. Jump conditionally. In conditional jump instruction, the jump is taken only if the condition is true. The program sequence is transferred to the memory location whose address by the 16-bit address is given in the operand based on the specific flag. I think as I was telling you, the conditions will be generated only if the flags are there. Okay, so X, can you see X, JX, X is replaced by any condition. So there are 8 conditions. This instruction belongs to immediate addressing mode. 3 byte flags are not affected. Program counter, as we have already seen. In conditional jump instruction, auxiliary carry flag is not used. I hope everyone knows that there are 5 flags: carry, parity, auxiliary, 0 and sign flag. Out of this, auxiliary carry flag is not considered. Okay, that's why we got only 8 condition, because either the flag will be set or the reset. According to that you will be getting the output. Okay, now I think this is very important. Can you see JC address X? Here C, we have just C for carry. So I think the first 2 instructions are for carry flag. If the carry flag is set, then only it will jump to that particular address. Jump if no carry, JNC address. So this is like 3 byte instruction. If the carry flag is reset, then only it will jump. JZ, jump if 0, so 0 flag will be set, then only it will jump. JNZ, if 0 flag is not set, that is 0, then it will not jump. JPE, that is jump if even parity. So if the parity flag is 1, then only it will jump. JPO, if the parity is odd. I think everyone knows about even parity and odd parity. It will just count the number of ones. If the number of ones are even, it will jump. If the number of ones are odd, it will not jump. Then JP address, jump if positive. So in this case, you have to consider sign flag. If the sign flag is 0, then it will jump. And in the next case, JM, that is jump if minus. So sign flag is 1, then only it will jump. So I hope you understood all the instructions. So there are 9 instructions for jump. One is unconditional and 8 conditional instructions. Okay, now let's see the program and let's try to understand. So please pay attention. I just written one program. Whenever you write your programs in your 8085, memory locations, labels, mnemonics, comments. Okay, out of this I hope you will understand the handwriting. I think, can you see C000 at first position we have written MVI A comma 25. Now whenever you write the comments, that time you have to use semicolon. That is also very important. Now A comma 25, that means accumulator value will be initialized to 25. Now since this is 2 byte instruction, so can you see we have written C002 next memory location. So MVI B comma 35H, so B will be initialized to 35. Again this is 2 byte, MVI instructions are always 2 bytes, that's why we have written C004. Now I'm just adding, add B. So I hope you understood. A is equal to A plus B. Okay, then I have just written C500 jump. Now this is very important. Can you see when we are seeing the example, that time we have written, this is J, this is JMP, jump address. Instead of address, I have just used a label. You can write anything like down, up, wherever you want to jump. So I hope you easily understand that. 1 minute. Easily understand that from here it's going to jump at this position. Okay, directly it is going to jump at this position. Okay, so so after this instruction is getting executed, it will directly come here. I think you can see that the last instruction is halt. Halt means stop. So after adding, it will jump here according to the programmer. So programmer wants that it should jump here. Okay, now let's see. I hope you understood. Then you will be thinking what will happen to these 2 instructions, move D comma A and move E comma A. Before that, I hope you can see that your jump instruction is of 3 bytes, so it starts from C005, and can you see the next instruction is written as C008 because of 3 byte instruction. I hope you understood. Now in this case, it is absolutely understood that these 2 instructions are never going to execute. Okay, these 2 instructions will not get executed. Now then you will be thinking, what is the purpose, why you written this? I think sometimes the programmer wants that he should stop the program and he don't want to execute this instruction. So in that case, this is unconditional. So without checking any condition, it will jump, and it is a choice of the program. But how you can end the where you want to, suppose you will be thinking, should I jump here only? No. Suppose if you want to jump at this position, it's your choice. Okay, but suppose if you jump at top, then it will become an infinite loop, because it will never end. Because suppose if you jump here, it will execute this instruction, again it will jump here, so that will become an infinite loop. So I don't want to go for infinite loop, I want to end the program, so I'll just come here. Now I hope you understood this much. Now before I go ahead, let me explain you how the programming is done. So what happens, you know, this address C000 will hold by program counter. Now what is PC? PC stands for program counter. So the program counter is a very important register. It is a 16-bit register which always holds the address of the next instruction to be executed. So it will always hold the address, and at that address whatever the opcodes or whatever the hex codes are there, that is given to the microprocessor, and then it executes. So if the program counter don't supply hex codes, then it will not in the sense the processor will not able to execute. So program counter is very important, and what it does, it just keep everything ready for microprocessor to execute. So in this case, what will happen again, as soon as this instruction is going on, it will be ready with this address. When this instruction will get executed, it will get ready with this address. When this instruction is going on, it will keep this address. Now the problem comes. Now what's the problem is, see, when this instruction was going on, actually if jump instruction was not there, then everything would have done smoothly in the sense it would have gone in sequence, this, then this, and then this. Finally the last instruction. Okay, but since we have just written the jump instruction, what happens? It will directly come from here to here. So how the program counter, or how they come to know whether you have to jump? Program counter has to be told that from here you have to jump it here. So this will be, because right now the program counter, you can see that right now the program counter is holding what address? C008, because after finishing this instruction, program counter's duty is to carry out the next instruction. The next instruction address is at C008. So program counter will always hold address. So that address is stored where? After this instruction. This is the next instruction which has to be executed. But a microprocessor is very intelligent. It will work according to the programmer. Programmer don't want these two instructions to get executed. So what he wants directly to go here. So now what will happen? Program counter address has to be replaced or changed. It was C00, now it has to be C00A. I hope you understand, because of hexadecimal notations, after 9 we cannot write 10, we have to write A. So from here you can write here. So program counter will not take this address, it will take this new address, and after this, suppose if the next memory address or whatever is there, it will get executed. So I hope you understood why we require program counter. Program counter is a 16-bit register which always keeps the address of the next instruction to be executed. But in case of jump instructions, it has to change the address because the programmer wants. The programmer wants to jump here. So and suppose if you don't give this address C00A to program counter, then what will happen? It will not execute. Okay, because program counter right now is holding this address, and the program execution will not take place unless and until you supply this address to the program counter. So I hope you understood, or you can imagine that this is a situation before execution. Okay, and this is the situation. Program counter will hold the new address known as this is after execution. Okay, so I hope you understood till here. Now what happens, let's take an example of any one of the examples of this. Okay, conditional instructions. So I'll just try to explain you conditional instruction. Now suppose, I think just now we have done the addition. Now there is a possibility after addition, I'm just assuming that after addition there is a possibility, let's assume the carry is generated. So what we would have written, like, so I'm just replacing this instruction to explain you, like JC. Okay, and suppose it will, after JC, what will happen? Don't think there is JMP, think that there is JP. So just replace jump by JC, JMP by JC. So what will happen? If this condition is true, then only it will jump here. And suppose, I think when we'll add this two, suppose 25 and 35, so I think your answer will be 5A, and we will not be getting carry. So in this case, what will happen, you know, this condition will become false, and these two instructions will get executed. I think the next two instructions are very simple, like I want that accumulator value to be given to D, I want accumulator value will be given to E. But I hope you got the concept that what is the difference between jump and jump. This is unconditional jump and this is conditional jump. Okay, I hope you got it. In this case, when you are writing conditional instructions, that time there is 50% chances that these two instructions are going to execute. But if you are writing unconditional instruction, there is a guarantee that these two instructions are never going to get executed. Programmer wants to stop the program directly here. Okay, so I hope it is clear. And out of this, all the instructions might not be used at all the places. It depends upon the situation where you have to use it. But I hope you understood jump instructions. Okay. Now in the same way, we also have the next group of instructions like call. Now call is also little bit tricky instruction or difficult. Please try to understand. These instructions are of two types: unconditional call and conditional call. Call instruction is used to call the subroutines. Now what do you mean by subroutine? This is a very important word, subroutine. You can say that subroutine is also a program only, but its memory location will not be same as of the main program. Okay, now I think I'll explain you the program at the end. Let's read this. Before the control is transferred to the subroutine, the address of the next instruction to be executed, that means program counter will come into picture, because address of the next instruction to be executed will be stored in the program counter of the main program is stored in the stack. Now there is a new word known as stack. I think those who have already seen paper 1, in that we are having data structure concept. In that we have already known the stack. Those who still don't know, I think stack is a memory location. I think subroutines and this subroutine and stack is a memory location. In stack, you can see entry and exit is done only at one end. So it works in a LIFO fashion, last in first out. Okay. Now I think that we'll see in detail. I hope you have seen in detail in data structure. No problem. Okay, let's go ahead. The contents of stack pointer are decremented by 2. Then the program jumps to the subroutine whose starting address is specified in the instruction. Right now you will not get this, but as soon as we will see the program, that time it will be more clear. Okay, let's go to the unconditional call instruction. Call address, unconditional call, unconditional subroutine call. The program sequence is transferred to the memory location whose address is specified by the 16-bit address given in the operand. Before the transfer, the address of the next instruction after the call, the contents of the program counter is pushed onto the stack. Suppose call 2034. So this 2034 will be stored in program counter. Okay, but after this instruction, whichever the address is coming, that will be held in the stack. Okay, and stack pointer will be decremented by 2. Don't worry, we will see the example, that time it will be more clear. Can you see CX? I think I should have written call X or CX. Okay, X stands for again conditions. Okay, this is a conditional call, conditional subroutine program. The program sequence is transferred to the memory location whose specified by the 16-bit address given. I think it is same. This instruction belongs to immediate addressing mode. Okay, 3-byte flags are not affected. Address will be stored in program counter. In conditional call instruction also, auxiliary carry flag is not used. Like in jump instructions, everything is same like jump instruction, but the main difference between jump instruction and call instruction is, in jump instructions the memory locations are same, but in call the memory locations are totally different. So let me explain you. But before that, can you see we are just replacing J by C, call on carry. So carry flag will be set, then only it will go to that memory location. Then call on no carry, CZ, that is call on no zero flag is set, CNC, that is zero flag is reset, CP, that is call on parity even, call on parity odd, CP call on positive sign flag, and call on minus. Now this is very important. Now let's try to understand. Okay, now can you see I've just written a program, a very simple program. Let's see, I have not written a proper program, but main thing I have written. So Can you see MVI A comma 02? So accumulator value is 02. It is incremented by 1. Now can you see, now let's talk about the how the sequence is going on. So program counter will be holding this address, program counter will be holding C002. Now what happens after this, program counter will also hold C003. Now after executing this call, when this call instruction is going on, it is also 3 byte. Okay, this call instruction is of 3 byte. Okay, now what happens after this instruction get executed, program counter right now the program counter is holding C006. Can you see? Okay, so program counter is holding C006. Okay, move D comma A, so A value will be given to D. Now this the program will halt here. Halt in the sense will stop. Stop in the sense I think we have to wait here. Okay, call D000. Call D000 means it will go here. D000 when the call instruction come. But before the call instruction, before the control is transferred to the subroutine. Can you see? This is your main program. This is your subroutine program. Now what happens, I think it is similar to like if we are going to our native, we will just keep our things to our neighbors and all, or to lockers or in bank. So I think after coming from this subroutine, 1 minute, suppose you go to this call instruction means you have to go to this position. Okay, 1 minute, you have to go to this position, but when you will come back, return is the instruction. Like one more thing you can easily identify, like main program will always end with halt and subroutine programs will always ends with 1 minute, return statement. Can you see return? Okay, return statements. Now when it returns back, it has to continue from here. Okay, so it has to, since it is a machine, it has to prepare everything and go. So what it will do, program counter right now is having this address C006. This is your stack. As I told you, stack is always working in D4 fashion. Suppose your stack pointer, to maintain a stack we require a stack pointer. Like how we are having program counter, it is also hold the address, but it will always hold the address of the top of the stack. So stack is right now pointing here. Okay, so the stack pointer is having this address E002. Okay, now this is before execution. Program counter is holding C006. Stack pointer is right now here, as we can see. Now what happens after execution? Now look here, after execution, whatever the address is there, because it will not go directly here. Okay, this address has to be stored in stack. So this 1 minute, this address is given to the stack. Program counter's address is given to the stack. Now can you see, whenever you give the address, it has to be written in reverse order, C0 and then higher order, then the lower order. Now whenever you add something on stack, stack pointer was initially here. Now you have added two I think 2 byte address. Okay, so stack pointer will be coming to this position. So stack pointer's new address is E000. Initially it was at E002. Now it has come to E000. Okay, that's why stack pointer is decremented by 2, because it was at E002. Now can you see, initial was this, now it is holding E000. So stack point, whenever you add something on a stack, stack pointer is decremented by 2. Remember that. Okay, and whatever this address is there, D000 will be given to the program counter. Definitely, if you don't send program counter here, execution will not start at all. It will not make 2's complement of these two numbers. I hope it is very, very clear. Again, I'll tell you what happens whenever the call instruction comes. I think program counter has to take this address. Okay, and it will be, can you see the memory locations are completely different. These memory locations are C000, C everywhere, but can you see the call address is D000 and here. So it has program counter has to take this address, but before going to that subroutine, it will do some homework. Now what kind of homework it will do? Whatever the address which is going to be executed next, okay, it will just keep it in the stack, okay, and stack pointer, it will take the help of a stack actually, okay. Without stack, call cannot take place. So stack will that means it will just keep everything with the stack pointer. Stack pointer will keep will help him out, okay. So stack pointer will take that address, okay, that address is stored in the stack, stack is decremented by 2, and whatever the new address is there with call, that is taken by the program counter. I hope you understood, okay. Please see the video again and again, and still if you have doubt, you can ask me, okay. We'll meet in the next session. Thank you.